Hello and welcome. In today's lesson, we are learning how to measure the energy content of food. So far, we've explored the human digestive system and how it breaks down various nutrients to provide our bodies with the energy they need. We've also talked about how enzymes help to break down food molecules like starch into simple molecules like glucose to release energy. In this experiment, we will gain a better understanding of these important processes by using calorimetry to measure the amount of energy contained in food. Before outlining the practical, let's take a moment to consider its importance. Firstly, understanding how to measure the energy content of food has direct implications for your daily life. Every day you consume food to fuel your body, but have you ever wondered just how much energy different foods provide? Food product manufacturers need this knowledge to measure how much energy is in food to put on nutritional labels. These labels enable you to make more informed dietary choices, helping you understand how the energy from the food you consume translates into physical activity and overall health. Furthermore, this experiment equips you with essential scientific skills, including precise measurement, data collection, and analysis. Calorimetry involves using a calorimeter to measure the heat released during the combustion of food, requiring you to carefully calculate changes in temperature and energy transfer. These hands-on skills are foundational techniques in many scientific fields. This practical also improves our understanding of biological processes, such as metabolism and energy balance in the human body. The energy you derive from food fuels every cellular process, from muscle contractions to brain function. By quantifying this energy, you develop a clearer picture of how different foods contribute to your overall energy requirements, and how this influences your body's metabolism. This understanding is pivotal for understanding dietary habits, nutrition, and health. Finally, calorimetry exemplifies the principles of controlled experimentation. Here, you isolate variables to measure the energy content accurately. By maintaining consistent conditions, such as the amount of food burned and the volume of water used, you ensure that your results are reliable and can be replicated. This practical therefore instills the importance of control in experiments, teaching you how to design experiments meticulously and draw valid conclusions. Critical thinking and a methodical approach are vital skills in scientific research and problem solving in everyday scenarios. Let's start by gathering our materials. Sam, what do we need?
So for this practical, we need a measuring cylinder, food samples, a boiling tube, a thermometer, a clamp stand, a mounted needle, a mass balance, a Bunsen burner, and a lab book.
Now, let's dive in and discover the science behind measuring the energy in the foods we eat. Begin by measuring exactly 25 centimeter cubed of water using a measuring cylinder. Next, carefully transfer the water into a boiling tube. This will serve as our medium to detect the energy released by the food sample through the rise in water temperature. Using a thermometer, record the initial temperature of the water in the boiling tube. This baseline temperature is required for calculating the temperature change caused by the burning food sample. Don't forget to make a record of this in our lab books, as this is important for our later calculations. Next, set up the boiling tube on a clamp stand. This setup is important to ensure we safely heat the water at a later stage. In the final part of our preparation, we need to weigh our food sample using a mass balance. Don't forget to record the exact mass in your lab book. In our next stage, we need to carefully set fire to our food sample. To do this, you must use a mounting needle to handle the food sample and carefully hold it in the flame of a Bunsen burner until it ignites. Once the food sample has been lit, hold the burning sample about 2 centimeters away from the boiling tube, which is fastened by the clamp. Allow the food sample to burn completely, ensuring as much energy as possible is transferred to heat the water. After the food sample has finished burning, use the thermometer to record the final temperature of the water. Note the increase in temperature, which indicates the energy released from the food sample. Once you have recorded the final temperature, repeat the steps with various food samples. This repetition allows for comparison between different types of food in terms of energy content. When repeating the experiment, note that it is important to manage the experimental setup to minimize errors. By consistently maintaining the same distance between the food sample and the boiling tube, and ensuring that the food burns completely, we can achieve more reliable results. Now it is time for our analysis. Draw a table in your lab books, which allows you to record the mass, the initial temperature, and the final temperature for each food sample. Fill this in as you conduct the experiment. Once we have recorded the initial and final temperature for each food sample, we can calculate the temperature increase by subtracting the initial temperature from the final temperature. Next, we can calculate the energy transferred by each food sample. To do this, we can use the formula of energy transfer per gram of food equals the mass of water multiplied by the temperature increase multiplied by 4.2, divided by the mass of the food sample. For this experiment, we know that the mass of water is 25 grams as 1 centimeter cubed of water weighs 1 gram, and we use 25 centimeter cubed of water. When using the example of the apple food sample, if the mass of the water is 25 grams and the temperature change 15 degrees Celsius, then the energy transfer per gram is 25 multiplied by 15 multiplied by 4.2 divided by 2, which equals 787.5 joules per gram. Once you have calculated the energy transferred per gram for each food sample, add a column to your table and record the results. This is useful as we can then directly compare the energy transferred by each food sample. One useful way to compare our results is to plot a bar graph with different food samples on the x-axis and their energy content in joules per gram on the y-axis. This visualizes which food samples contain more energy. In this format, we can analyze the results to determine which food samples have the highest and lowest energy content. The final step that remains is to assess elements of the practical experiment overall. Firstly, let's consider some of the key steps of the practical and their importance. For instance, we measured water volume precisely to ensure that the specific heat capacity calculations remain consistent and precise between samples, as the same amount of water is being heated each time. We also measured the initial temperature of the water, which provides a baseline, allowing us to calculate the exact temperature increase once the food sample is burned. This step ensures that the energy gained by the water is due to the food sample. Furthermore, we weighed the food sample before burning it, which is essential for calculating the energy per gram of the food. This ensures precise comparisons between the relative energy content of different food samples that may differ in mass. These steps are therefore important in ensuring the validity of the experiment and the calculations. During our analysis of the experiment, we should also consider the limitations and any potential improvements. These include potential experimental errors like incomplete burning or heat loss to surroundings. Discuss how consistent procedures and additional measures, such as using a calorimeter with minimal heat loss, could improve accuracy. By carefully analyzing and interpreting the results, you can draw meaningful conclusions about the energy content of various foods and understand the practical applications of calorimetry in determining dietary energy values. In today's lesson, we conducted a practical experiment to measure the energy contained in food using calorimetry. Our key takeaways from this practical are to ensure accurate measurements of mass and temperature for reliable calculations, to be aware of heat loss to the surroundings, which can affect results, and to understand the importance of repeating experiments for consistent data. This practical not only reinforces our understanding of how we measure the energy content in food, but also provides insights into the energy transfer processes, highlighting the importance of precise data collection and analysis in biological experiments. Watch the rest of the GCSE biology course at Sophos Education.